In this video, we are going to study about the methods for solving the problems of indefinite integrals. Right? There are few methods which are used to solve the problems of integrals. Right? Basically for indefinite integrals. So we have basically three methods. Okay. The very first is integration by substitution. Then we have integration using partial fraction and then integration by parts. For these three methods, you must having a knowledge of basic formulas used for integration, basic integration of simple functions, right? So let us move forward and understand these three methods. The first is integration by substitution. Let's understand integration by substitution. So basically you have to decide like which method you are going to use for integration. Okay. So the first is integration by substitution. Now in which type of function you are going to use this method is if you are having a function, okay, for this, if a function and its derivative both are present in the function, in the given function, right? This is what you have to remember for substitution, right? Now you will understand this concept when we solve the problems. So let us first understand what is substitution method. If you have to find the integration of fx dx, right? Now I will change this x, right, which is an independent variable, into t, which is dependent on x, right? I will be changing or substituting x to t, which is dependent on x. This t is dependent on x. So this x is equals to g of t. Right? This is a second function. Right? Now if you differentiate both, what you will get, dx is equals to g dash t, right? This is the differentiation of gt. Into dt. So this is your dx is equals to g dash t. Basically what you are doing is you are differentiating it with respect to t. Okay, you are differentiating it with respect to t. So what you will get here is, see, I am writing over here, dx by dt is equals to g dash t, right? Because we are differentiating it with respect to t. So you will get this. Okay. So this is your second equation. Now what you can do is you can just substitute it. You can just substitute these values of first, this is your equation third. Now what you are going to do is substituting first and second in third, basically, right? So what you are going to get is, it would be f g of t, right? And this is g dash t dt. So this is basically changing the variable x into variable t, which is dependent on x, and you will just substitute these two values and you get the substitution method, right? This will end your substitution method. To To understand this concept, we'll take one example which will give you a basic idea about what is the method of substitution and how you can see from the function itself that what method you are going to use, whether you are going to use substitution, partial fraction or by parts, what you are going to use. So let us move forward and understand it using one basic question. So let's take a basic example. For example, if you have to integrate x, basically this is your fx is 2x sine x square plus 1. This is your function. Now how you will see that whether you are going to do the substitution or not, right? See, this is the function in a function itself. So this is a function in the function itself. This can be represented as the different function. This can be g of x, it is x square plus 1. Okay, so this is a function in function itself. Now if you differentiate this, right, if you differentiate this, what you will get? You will get 2x, right? So this is what I was talking about. If you get the function and the derivative of the function in this function itself, right, you are getting function as well as its derivative. This is g dash x, right? So both of these you are getting in this function itself. So in this we can use the substitution method. Now how you can do the substitution? See. Okay. How you can do the substitution? First we'll take let t is equals to x square plus 1, right? Now if you differentiate both sides with respect to t, right? So it would be dt twice of x and this will be 1. So dt will be 2x, right? Now you are substituting this into this. These both values you are substituting here. So what you will get is integration of 2y of x sine x square plus 1, right? If you change it into, now it will be changing into, this is your sine of t and this is your dt, right? So you can write it as sine t and dt, because you are putting this first and second in this, right? So you will get sine t dt. Now you know the differentiation, integration of sine t, it is minus cos t. So you will write it as minus cos of t plus c, right? Now again substituting value of t, right? Value of t is what? X square plus 1, so you will get minus cos of x square plus 1, right? Plus c. So this is your answer, right? So this is how you are going to solve the problems of substitution. Now before moving on to the second method, there are few important functions and their derivatives, right? Their integrations, right? You have to remember these formulas so that you can easily solve the question. There are some special functions, right? Some type of special function that you must remember. So the very first is if you have x square minus a square, now there is one similarity in all of these formulas, it's that it is a squares, right? If you have squares in the denominator, right, these are the squares, x square plus a square, x square minus a square. So these are the possible functions, right? X square minus a square minus x square plus a square. So these are the basic terms, right? So if you have minus, right, so you have to remember is 1 upon 2a, it will be twice of a, log x minus a, x plus a, right? Since a is the first, so you will write a plus x and a minus x. See, these are just inverse. If you remember one and remember first formula and just do the inverse of it, right? Here you write a plus x, here you write a minus x, right? So you can, if you remember only one formula and remember that second formula is just the inverse of first. If you have x square plus a square, right? Now you don't need 2a, it's 1 by a, 10 inverse x of a, right? So see, if there is positive sign in between, right? If there is positive sign in between, then you have to remember it with 10. Okay, 10 is always positive. So you can remember it like this. If you are having positive, then you have to use 10 inverse x by a. Okay, and if it is negative, then these are the formulas. If you have under root, right, then it is log of x plus, similarly it's the under root plus c. Okay, these are the direct formulas which can be used to solve any of the questions, right? So let us take an example and understand how you can directly implement these formulas of integration, right? You have to just convert the function into a perfect square. Now let us take an example, right? If you have to integrate d of x, right, and now you have x square minus 6x plus 13, right, and you have to integrate it. Now since from the question itself you can understand that this is going to be in the form of d of x, x square plus a, or a square, or d of x, x square minus a square, right? It can be converted into this format. Now what you are going to do is you have to equate it with the x square plus y square plus 2xy, right? It can be plus or it can be minus, right? So for this, it is, we have x square, we have no y square is there because 13 is not a perfect square, right? So this is your 2xy, right? So how you can equate it? You can write it as twice of x into y is equals to minus of 6x, right? So y is equals to minus of 3. You get the y, right? This is how you get the y. This is your y. Now you need y square. So y square is what? Minus 3 whole square, right? This is your y square, that is 3 whole square, right? Now you can simply write it as dx. Here you can write it as x square minus 6x, right? Now you need y as minus 3, right? Y is your minus 3 basically, right? So you have your minus over here, so it will be your plus 3 square and minus 3 square, right? Plus 13, right? So this is your basic formula of x square. So this is your basic formula, d of x is this is your formula, and this is your x minus 3 whole square, right? And what you get over here is it's 12, it's 9, right? And you get what? You get plus 4, right? So plus 4 can be written as 2 square, right? So this is your conversion. Now you know the basic formula. If you have x square plus a square, what is the formula? If you have dx upon x square plus a square, right? Then you know the formula. It's 1 upon a tan inverse x by a plus c, right? Now you can see this is the basic formula. This is your x and this is your a. Now what will be the answer? It would be 1 upon a is what? This is your a and this is your x square, right? So 1 upon a tan inverse x is what? X minus 3 upon 2, right? Plus c. So this is your basic solution. So if you find such type of problems, you can just change it into a perfect square and you can solve the question. So this completes your method of substitution in integration. Now in the next video, we'll understand the remaining two methods, that is the partial fraction method and the integration by parts. Okay, so we'll understand these two topics in the second video. So this completes your methods of substitution, as well as there are some basic important formulas which can be directly used to solve the functions or integration of a function. These basic formulas, the four formulas that are the formulas for the square of squares that can be formed inside a function, right? Changing the function into a perfect square, and then we can use those formulas directly to solve the integration. Okay, thank you for watching.